Okay, so today I'm going to go through my secret formula to get an A star on the 0607 iGCSE. Hi, I'm the Ginger Mathematician, and I'm going to go through how you can, with a secret formula, actually achieve that A star at iGCSE Maths. And the first thing that we need to be aware of course, is what you actually need to get an A star. So what I've done is I've gone through all the grade boundaries of the last 4 or 5 years, and then try to distill exactly how much percent you need to get a A star. And now you're going to see on the side over here exactly what you need to get an A star. And generally it's around about 85%. Okay, and this can often change from paper to paper. Now you'll notice that an A, and a B, and a C kind of stays around the same, 65%, 50%, and 35%. But what you need to achieve is around that 85% mark. And what that means is then you need to focus on that top 35% of questions on paper 2 and paper 4. And where did I get the idea for this video? Well, I've been putting more questions out in my community page to really see exactly what you need for your iGCSEs. And the first thing I noticed is I did a quick poll, and many of you asked that you're actually aiming for that A star. And secondly, I then asked directly if this kind of video would be really useful to you, and it was an overwhelming yes from yourselves. So what I've done here is actually create a PowerPoint, actually taking lots of these really difficult questions from paper 2 and putting it into one PowerPoint. You'll see the link in the description below, and I'm going to go through some of these questions and really aim on those really harder questions, exactly how we go about answering these questions. Okay, so let's go through these questions that are going to make the difference between you getting an A and you getting an A star. So the diagram shows the graph of y equals the modulus of ax plus b, where a is greater than 0. We need to find the values of a or b. So notice it's a modulus function because it has this kind of what I call bouncing effect. So it bounces off the x-axis and then goes upwards. And the way to actually approach these questions is imagine it doesn't bounce and then see what the equation of that line would be. Okay, so I'll write in bouncing effect because of the modulus part. So imagine I take this graph and I just continue. So imagine I just continue. And then I need to think about, okay, what would the equation of this line be that would actually continue? Well, because you've got this symmetrical effect of this being plus 4, this down here will be equal to minus 4. So essentially we have a question here. I kind of broke it down to an easier question where we've got a line that goes upwards like so. We've got the y-intercept of minus 4. And all we now need to do is work out the gradient of the line to work out the value of a. Well, we can actually do that by using the two coordinates here. So if I want to work out the gradient of this particular line, well, remember it's the change in y, so change in y over change in x. So if we use this particular formula, well, notice we've got a change of 4 here for the y. So the difference between 0 and minus 4 is 4. The difference between 0 and 2 is 2. And so we get 4 divided by 2 is equal to 2. Now notice it can be a positive 2 because the gradient of this line is going in the positive direction. So that's why it's going to be positive 2. So the answers to this is going to be a equals to 2, our gradient, and then the y-intercept, which is minus 4. So in fact, this is the function, the modulus of 2x minus 4. Now, why is this considered a star question? Well, this doesn't really come up very often. So that's number one, it doesn't come up very often. And two, it's going to take a topic that's taught, of course, on this course, but not in any great depth. So you don't really get the experience of questions that you say would on cumulative frequency. You can see the answers here. You get 1 mark for each. Now, another typical kind of question that they put towards the end of a paper 2, so this is what we're focusing on today, is some more difficult factorization. And they like factorization on this course as well, and then at the harder end they make the factorization a bit trickier. Okay, so this is question 16. So the way we approach this is we're going to put into brackets the numerator and denominator. So we look for the common factors here. So what do these two things have in common? Well, they have an x in common and they have a y in common. So we're going to put xy outside, and then we're going to work backwards. So what do we multiply xy by to get x squared y? Well, we multiply by x. And then what do we multiply xy by to get minus 3xy? Well, that's going to be minus 3. And a little handy hint here in these kind of questions. If you get a bracket in the top, then you probably know there's going to be a bracket of x minus 3 in the bottom as well, so that some cancellation can occur. Now, of course, we're going to do this without knowing that fact, but just keep that in mind for these AA star questions. They'll ensure that there's a bracket above and a bracket below that does cancel. Now, if we factorize this, because we've got 1, 2, 3 terms, an x squared term, an x term, and a number, this is going to go into 2 brackets. Because we have an x squared, we're going to put x at the front. And now we're looking for 2 numbers that multiply to give me minus 3, but then add to give me minus 2. Well, what numbers could they be? Well, a minus 3 and plus 1 fits here. Minus 3 times 1 is minus 3. Minus 3 plus 1 is equal to minus 2. So we can factorize this. And lo and behold, we do have a bracket that's the same above as below. And the whole point of this process is that we cancel this. And so we're left with just xy over x plus 1. Okay? If you're liking this video, then please do consider giving it a like. It does really help the algorithm. It makes the algorithm know that you like this kind of content. You can see the answers just in front of you. Now we go on to this kind of question. Now, on 0580, this is quite common, whereas on 0607, it's not so common, which is one of the indications of an AA star question. So the diagram shows the line x plus y is equal to 8. On the diagram, clearly the region defined by the inequalities. So notice we've already got this line, x plus y equals 8. That's kind of helpful. And we're going to look for x plus y is less than or equal to 8. So we're going to consider everything below the line. But we need to put in these 2 inequalities first. Before then we can decide exactly where the region is. Now, the approach you take on these kind of questions, imagine it's an equality. So imagine this is x is equal to 2, and this is y is equal to 3. So we're going to draw those lines in. Now remember, any x equals line is going to be a vertical line, whereas a y equals 3, that's always going to be a horizontal line, anything y equals. So x equals 2, so we're going to draw a vertical line. Now this is a filled in line because it's greater than or equal to. So I'm just going to draw a line all the way up, just like so. And then for y equals 3, well, we're going to draw a horizontal line all the way across, just like this. Again, my drawing on the computer is not particularly good. And now we need to work out which part of the diagram they actually want us to consider. So let me change over to the red pen. So I told you that it's below the line here, below this diagonal line. X is greater than or equal to 2. So we want everything greater than that. So it's this line here. So we want to go in this direction. And then finally, everything less than or equal to 3. So we want everything less than this particular line. So we want less than this, but greater than this. This is where I do my little arrow thing. And then we see we actually want this region here. So we're just going to shade in. Make sure you shade in the whole region properly as well. Don't leave any gaps, etc. So it's very clear that we want this particular right-angled trapezium like so. Okay, and you can see in the mark scheme, I actually want this part here. Notice I also need to include down here as well. So I did forget to put that in. Oopsie on me. So we need this entire trapezium here. Okay, if you use this arrow method, then you know it needs to be less than this, and then greater than this. This then gives you an idea of exactly what shape they're looking for. A typical mistake, which I made there accidentally on purpose, is that remember you do not stop at the x-axis here. You need to include the entire shape here. Okay, so we'll go on to the next question. Again, rearranging to make equation to make x the subject. Very typical, particularly when you've got x's on both sides, because you have this factorization that happens later on. Let me go through this question. So the first thing we're going to do here is we're going to cross multiply. So like this. So we get a times 5x is equal to b lots of 2x minus 3. This cross multiplying effect because we have the equals in the middle. Then we're going to multiply this out. So a times 5x is going to be 5ax. b times 2x, well, that's just going to be 2bx. And then b times minus 3 is minus 3b. Now, the key strategy in these kinds of questions, and I'm going to write this down as my strat, cool word, is we want to put everything with x on the left-hand side and everything else on the right-hand side when you ever have these kind of problems. So I'm going to follow those instructions now. So I'm going to bring the 2bx to the left-hand side. So we're going to minus 2bx from both sides. Now, if we do that, we get 5ax minus 2bx is equal to minus 3b, like so. And now we can take out the factor of x. This is the most important step. So they both have x in common. And then we see what we're left in our bracket. Well, what do we multiply x by to get 5ax? We just multiply by 5a. What do we multiply x by to get minus 2bx? Well, minus 2b. And once we've got this, notice we only got a value of x now. We don't have two terms with x, just one. And then we just divide by the bracket. So we get x equals minus 3b over 5a minus 2b. Okay. Now you could change this and multiply through by minus 1. Interesting to see if the mark scheme insists on that. They're happy with exactly how I've written it here. Notice if you multiply by minus 1, top and bottom, you get this expression here as well. You can see where you're picking up the method marks too. And on to this question. This is often tricky because this is the typical non-calculator trig question that is quite difficult for this particular level at iGCSE. Now, the first part should be reasonably straightforward if you know your exact values. So sine x is equal to a half, and we have the domain between 0 and 90, and we need to work out what x is. So what's the opposite of sining something? Well, inverse sine, so sine minus 1, as some people call it. We do the same to both sides, so this cancels here. So we get sine inverse of a half. Now this is one you need to be able to recognize. So this is what we call an exact value question. So what do I mean by exact values? Well, let's write down sine 0, sine 30, sine 45, sine 60, and sine 90. It's useful for the next part anyway. So you need to know these values off by heart, or at least be able to derive them, work them out. So sine 0 is equal to 0, sine 30 is equal to a half, sine 45 is equal to root 2 over 2, sine 60 is equal to root 3 over 2, and sine 90 is going to be equal to 1. If you don't know these values, you need to learn these off by heart. There's the finger method you can do to learn it. You can also use the triangles as well. So what I've done is I've memorized these kind of triangles off by heart. So this is where this is 2, this is 1, this is root 3. We're using, this is 60, this is 30, and then if I want to work out sine 30, I just use SOHCAHTOA. Sine 30 equal to opposites over hypotenuse, so that's equal to a half. So what I want to do here is actually work backwards. So if I highlight this one here, you'll see that I put sine 30 is equal to a half. Therefore it means that the inverse of sine of a half is equal to 30. Notice it's just the opposite operation here. And it helps if I don't use a highlighter and actually use the pen function instead. That would be very helpful. There we are. So this is equal to 30 degrees. Now many of you might have got that at home and just aware that sine 30 is equal to a half. Therefore the inverse sine of a half is equal to 30. Where students often fall down is this kind of question here, so part B. So sine x equals minus a half between the domain of 0 and 360. And generally the way I teach this at iGCSE level is to use the symmetry of graphs. So if I draw the graph of sine between 0 and 360 degrees, remember this is a non-calculator paper, so I pop this in at 360 and pop in the kind of normal values of 90, 180 and 270. If I draw the graph here, let's we do this in green, notice it follows the values I put here. So it goes up to 1, because sine 90 is equal to 1, sine 180 is equal to 0, sine 270 is equal to minus 1, and sine 360 is equal to 0 again. If I just put on the labels here, so this is equal to minus 1, and this is equal to plus 1. Notice sine 30 was equal to a half, so if I read this off at 30, this is equal to a half, or 0.5. What the question's asking for here is actually when it's minus a half. So if I put in minus 0.5 and I go across, it essentially wants me to read off this value here and this value here as well. So work out where it is on the graph. So notice the distance between here, 0 and 30, gives me a half here, and it's the same distance as it is here. So to go from 0 to 30 is 30. What do I need to do from 180? If I go 30 along, what value does that give me? Well, this is going to be equal to 210. Likewise, working backwards from here, this is 360. This distance is always going to be equal to 30. So if I do 360 minus 30, we get to then 330 degrees. So the two answers to this question, what the question is looking for, is these values I've just worked out here and here. So the answer is going to be x is equal to 210 degrees and then 330 degrees. Notice both of which lie between the domain we're given here, 0 and 360 degrees. Okay, now the mark scheme doesn't really help you with this, it just tells you the answers that I've just given you here. And this is why hopefully this video is really valuable to you. I explain some of the really more difficult questions on the paper. Okay, and one more question I want to go through here as well. So we need to find the next term and an expression for the nth term of the sequence. So we've got 35, 29, 19, and 5. And the general standard practice for any nth term question, so if you see nth term of sequence, is look for differences. So if we look at the differences here, well, we've got a difference of minus 6 here. 35 minus 6 is 29. Then we've got minus 10. And then we've got minus 14. Okay, then we look at the differences of the difference, so the classic difference of difference. Well, to go between minus 6 and minus 10, that's minus 4, and that's also equal to minus 4 as well. So we have a difference of minus 4 here and minus 4 here. So we know it's a quadratic sequence of some kind. So if we get a second difference, it's the same. We know it's quadratic in the same way. I teach this slightly differently to other teachers. The way I would do this is I take the minus 4, and the first thing we do is divide it by 2. For any quadratic sequence, we take that second difference, divide by 2. That gives us minus 2. And that tells us that I need to write out the minus 2n squared numbers. So what that means is I need to write out the square numbers and multiply them by minus 2. So if I do that, well, my square numbers are 1, 4, 9, 16, 25. So those are my numbers. So I'm going to take each number, each of those square numbers, and multiply it by minus 2. So 1 times minus 2 is minus 2. 4 times minus 2 is minus 8. And that times minus 2 is minus 18. 16 times minus 32, and the next one is going to be minus 50. Okay, so we have minus 2, minus 8, minus 18, and so on. And what we now need to do is look at what do we need to do to minus 2 to get to 35. Well, we need to add on 37, yeah? And what do we do to minus 8 to get to 29? Well, we need to add on 37. What do we need to do to minus 18 to get to 19? We add on 37. And you can see that each time it's going to be adding on 37 each time. So our nth term, so the answer to this, is going to be minus 2n squared plus 37. And in fact, it wants us to work out also the next term in the sequence. Well, we can actually see this, it keeps going by 4s, so we're going to go minus 18. And 5 minus 18 is equal to minus 13. I kind of got so involved in the A-star part of the question, you also need to put the next term in there as well. So you can see the answers here. I've just written it the other way around, minus 2n squared plus 37, but it's still the same idea, still the same calculation, like so. Okay, and the question I want to go through now, question 12, again, is another rearranging question, similar to what we did a little bit earlier. Again, same procedure applies. The first thing we're going to do is get rid of the fraction element of it. So the way we get rid of this fraction, so the opposite of dividing by 3x is timesing by 3x. So we do that to both sides of the equation. So we get 3xy is equal to a minus x, because these two things cancel. Again, the same strategy as before. You want to make x the subject, so we write the strat. So everything with x on left-hand side, everything else on right-hand side. So in this question, we want to bring the x to the left-hand side, so we need to add x on both sides. If we do that, we get 3xy plus x is equal to a. Then we do that factorizing process that a lot of students miss. So we're going to take a factor of x out here. What do we multiply x by to get 3xy? Well, just 3y. What do we multiply x by to get plus x? Well, just 1. And then we can just divide by the bracket, so we get our final answer, x equals a over 3y plus 1, which we can just write over here. You see the same answer as before. So one of the key things with A-star questions also, you need to do this at speed. You're getting best part of 3 or 4 minutes for this kind of question, so you need to be able to recognize what kind of question it is, know the key strategy here, which I wrote up on the board, and then apply that effectively as well. Hopefully you found that really effective of how to actually revise to get an A-star on your paper 2. Link is in the description below for Google Drive link, so it's got the PowerPoint there in case you want to go through any of these questions yourself as well. And if you like this kind of video, I'm happy to add to this PowerPoint as well, so I can go through more A-star questions or A-star questions that you actually find that you're stuck on as well. All right, if you're interested in doing more paper 2 revision, then do check out the video right over here, so it goes through a complete paper 2 walkthrough.